A population of values has a normal distribution of mean mu to 215.8 and sigma, which is also the standard deviation, 5.1. You intend to draw a random sample of size n equals 51. Find the probability that a single randomly selected value is between 214.1 and 216. So this is just a single one. So this you could just use the mean and standard deviation of the original distribution. You don't have to use the sampling distribution of the sample mean to find this one. And because it's just you're finding the probability of a single value being between that, you're not finding the probability that a sample will have a mean between that. So this is not the sampling distribution. This is the original distribution of this population. So we can just do normal CDF. And they do say it's the original distribution has a normal distribution. And the lower bound is going to be, and we could do the drawing, which is, I believe it's good and helpful to understand. It's normally distributed, so it's a bell shape. And then the mean is 215.8. And you want 214 and 216, so that 214 is a little bit below. Well, I'm not sure how far below. I don't know where the standard deviation is. I didn't, but we're just going to say it's right here. And then let's see, this is 216 above. That's probably a lot closer in. I'm not drawing this to scale, but let's just say that's about what it is. We're trying to find this area under the curve. So to do so, we find the normal CDF function, put the lower bound where the shading starts. And I always put my smaller number in first and my larger number in second when I'm describing this interval where the shading is happening. So 214.1, comma, the upper bound is 216. And then my mean is the 215.8. And 5.1 is the standard deviation. And that's what I input in my calculator. And second bars, normal CDF, 214.1, comma, 216, comma, 215.8, comma, 5.1, and we'll have our answer here. So the probability that that a single randomly selected value is between those two is 0.146 or approximately 14.6%. So let's just double check that answer. Let's make sure that it accepts that. So 0.146, and let's just submit it, make sure it's okay with it. And yep, it likes that answer. Okay. Let's go on to the next part of this. And you have to be careful, really careful about sometimes the homework program is very picky. It may want exactly 4 decimal places. It may want 3 decimal places. So just be careful I have here, enter your answers as numbers accurate to 4 decimal places. Answers obtained using exact Z-scores rounded to 3 decimal places are accepted. Okay. So make sure that you list pay attention closely to the rules that they have about how many decimal places they want you to round to. Okay, second part of this problem. Find the probability that a sample size of 51 is randomly selected with a mean probability between 21.4 and 216. So the same upper bound and lower bound as before, except for now we want the probability that a sample will have a mean between that value. So we need to look at the sampling distribution of the sample mean. And to do that, first we ask, is it normally distributed? And if the original distribution is normally distributed, which it is, then this one will be normally distributed. Also, if n is greater than 30, which it is. So we do know this sampling distribution, or the sample mean, is normally distributed. So, and we would follow the formulas to find the mean and standard deviation of that distribution. So mu of the mean of the distribution is just going to be equal to the mean of the original distribution. That's just the one they gave you in the beginning. That's equal to 215.8. That's convenient, right? And then this standard deviation is going to equal to the old standard deviation, the original standard deviation they gave you, but divided by the square root of n. So that's going to equal to 5.1 they gave me here in the beginning, but divided by the square root of 51. That's where I'm getting the 51 up here is n equals 51. And they reminded us down here as well. Sometimes you can put that straight into your calculator because you don't want to truncate this. Ideally, you wouldn't truncate any numbers. You'd put all of them into this normal CDF. So again, it's between 214.1 and 216. We're going to see if this area is larger or smaller than the one above. So to find that area, I need to do normal CDF since it is normally distributed. The lower bound again is 214.1 and the upper bound is 216. And then the mean here stays the same, 215.8. But the only thing that really different changes in our calculation when we're working with the sampling distribution of this sample mean is that the standard deviation does change. So now it's 5.1. I'm going to put that in divided by the square root of 51. I'm going to put that into the normal CDF function as is to make sure I get all my decimal places. So let's put that in. Go to second vars and then put normal CDF. Put the lower bound in is 214.1. And then the upper bound is then comma. $216, and then comma the mean 215.8, comma 5.1 divided by second square root of 51. And I just close my parenthesis, and then that's 0.61 or 0.6016. So I think they say round to 4 decimal places. Yes, 4 decimal places. So 0.6016, and the 3 would round down. So 0.6016 is our answer. Answer is 0.6106016. And let's just double check it. 0.6016 is the correct answer. Let's just make sure it takes it. Yep, all right. So that's how you would do these problems. All right, thanks, bye.